results right now. Quiz number 2. Got to go with my favorite student. Alrighty. Lithium chloride, starting you off not too bad because I think this crisscross worked out perfect. I would go like this though. I would say, okay, it's Li plus and it's Fl minus. And when we do the Cl minus, that's what I meant to say. It's Cl minus, thank you. When you crisscross, you'll just get LiCl. That gets you 1 mark. Number of atoms, 2. That gets you 1 mark. SCBr3. So at first I'm going to say scandium bromide, but I have to check if scandium is multivalent, and I don't know. It's not. So if it's not multivalent, Mara, no Roman numerals, no uncrisscrossing. Pause the video for my little late continue. So I looked, I think this one then, remember the metal, we just keep the name the same, so it would be scandium. It's not multivalent, so no need for Roman numerals. Bromide. I would probably mark that half mark for the scandium, half mark for the bromide. Number of atoms, 4, yes? Magnesium. Is magnesium multivalent? It's not. So it's going to be magnesium, which is 2 plus, and nitrogen, which is 3 minus. And when I crisscross, do you get Mg3N2? So half mark for the Mg3, half mark for the N2. And how many atoms grand total? 5, yes? MgCl2, magnesium, I just said, was not multivalent. So it's going to be magnesium chloride, no Roman numeral. And that has 3. All right. Iron 2 bromide. Now this is multivalent because of the Roman numerals. Although when you give me the formula name, it's actually easier because they've told me the charge on iron. What's the charge they want me to put on iron? So it's just going to be, I don't even need to look it up, Fe2 plus. Br is 1 minus, yeah? You're probably at the point where you've started to memorize some of the more common ones, and that's fine. Although I always check when I'm writing a test just to make sure I haven't foolishly memorized them wrong. You want to be a little paranoid. When you crisscross, you get FeBr2, and that has 3. Half mark for the Fe, half mark for the Br2. Cobalt is multivalent, isn't it? Ugh. Okay. The trickiest is stuff like that, where you give me the chemical formula for a multivalent, and I have to then work out what the charge must have been. I always start with the non-metal. So selenium I looked up, and selenium has a charge of 2 minus. So how many negative charges do I have grand total? 2. How many positive charges must I have grand total? 2. How many cobalts do I have? 1. So each cobalt must be, that would give me a crisscross and reduce to 1 and 1. So this is going to be cobalt 2 selenide. Half mark for the cobalt 2, and you have to have the 2 there. Half mark for the selenide. And this has...
what if you don't have the 2 then?
Then you lose the half mark.
Okay.
So half mark for the cobalt 2, and you have to...
Oh, right.
So in other words, each line is worth 2 marks, because there's 2 different blanks you're filling in. I'm not really going to do a different half mark for the numbers. It's one all or nothing for the number of atoms. Beryllium. Is beryllium multivalent? No, it's not. Good. Nitrite. Most common mistake I see on these, Brianna, kids go, oh, beryllium and N. Is nitrite N?
No.
Oh, it's a polyatomic from the back of my sheet. Now, beryllium has a charge of 2 plus. I should have written that in before I forget. Nitrite, I have no idea. NO2 negative. So now when I crisscross, it looks like I'm going to have 1 beryllium and 2 NO2s. I can make that a little bit bigger. Half mark for the BE. Half mark for having an NO2 in brackets with a 2. How many atoms are there? So there's 1 beryllium, I'll remember that. Inside the bracket I have 1, 2, 3. Times 2 is 6. Plus the 1 beryllium, 7 atoms. SrOH negative. Sr is Sr, that's strontium, I think. Is that multivalent? Where the heck is strontium? Oh, there, 38. Oh, it's not multivalent. Cool. So I can just say strontium. What do I call OH? Hydroxide. 1 mark, sorry, half mark for the strontium, half mark for the hydroxide. How many atoms? 2 inside there times 2 is 4 plus 1. Is it 5? Yes? Okay. Lead 2 cyanide. Now this isn't too bad because they've told me that the lead has to be 2 plus. Because it said lead 2. Cyanide. Yes, that's the poison. Cn minus. When I crisscross, looks like I'm going to get 1 lead and then 2 CNs. Is that right? So half mark for the PB, half mark for having a CN in brackets with a 2. How many atoms? 1, 2, 3, 4. 5 again? What the heck is IR? Iridium, I think. Not iron. Why isn't IR iron? Because it's not. Iridium. Ooh, multivalent. Element 77. Okay. So I have to uncrisscross. How many PO4s do I have? 1. What's the charge on 1 PO4? I don't know. 3 negative. So how many negatives do I have in grand total? 3. How many positives do I have to have in grand total? 3. How many iridiums do I have? 1. So that's got to be all 3. So it's going to be iridium 3. So it's going to be iridium 3, and PO4 is phosphate. Half mark for the iridium 3, half mark for the phosphate. How many atoms are there? No brackets, so I can just count 1, 2, and then 4 oxygens, 6. When we got to the Bohr diagrams of lithium oxide, you're going to do a lot more of this in Science 10. I haven't done a big song and dance about it. I'll probably put 1 on your test. What do I mean by Bohr diagrams? Well, the first thing you have to ask is what kind of a compound is this? Ionic or covalent? And how do I know? That, by the way, that will be questions on your test. I'll give you compounds and ask you to tell me whether they're ionic or covalent. That we can tell at a glance. If it's ionic, what does it start with? Metal. If it's covalent, it starts with a non-metal. Okay? The only exception is it could be an ionic. There's the 1 positive polyatomic ion. So if it starts with NH4 and then has a non-metal, that's also an ionic compound. So this one, ionic or covalent? Ionic. So how do you write ionic? Covalent is where they shared electrons. Covalent is where we had overlapping electron shells. For ionic, all we're going to do is this. How many lithiums are there? How many oxygens are there? I'm going to draw this as a crystalline structure, what we called an ionic or a crystal lattice, an ionic lattice. How many lithiums are there? How many oxygens are there? I'm going to put the oxygen there. I'm going to put the lithiums there. But it's going to be a little bit bit better than that. I'm going to do the oxygen first. So oxygen looks like this. Oxygen has 8 protons, 8 neutrons, 2 electrons, and then 1, 2, 3, 4, 5, 6. That's an oxygen atom. This is now an ion. So how do I make it an ion? Okay, I'm going to change colors so you can kind of just see where the electron came from. That electron came from one of the lithiums. That electron came from the other lithium. Since it's an ion, I show that by putting square brackets. And I would put the ion charge of 2 negative. Then there's going to be a lithium on either side. You could put the lithium top and bottom, except there's not much room to do it that way. I'm going to put the lithium on either side. So there's going to be a lithium. Lithium has 3 protons and how many neutrons? 4? Lithium has 2 electrons on the inner shell. Don't write this next bit down. Normally it has that right there, except it just got rid of that electron. That electron right there, Marco, ended up there. So I'm going to get rid of that. This is an ion. How do I show that it's an ion? Square brackets. I'll take questions in a second. Put a plus sign there. Then I need another lithium on the other side. Copy. Paste. You can't do that, but for what it's worth, that's what you would do if you were handwriting. You would rewrite it. Now, as I was wandering around, I noticed a lot of people did these wrong. I'm going to suggest before you hand your quizzes in today, if you want to do your quiz corrections later on in class and then just hand them in then, do your corrections and change your score. You asked, what if we did them wrong? I'm going to say, why not fix the mistake and do it right so that you'll do it right for the test while it's fresh in your brain? Answer your question, okay? So mark yourself harshly on this, knowing that you're going to do the corrections and fix it. Yeah? Okay. NAF, ionic or covalent? Oh yeah, turn the page over. Ionic. How many NAs are there? How many fluorines are there? So it's just going to be 1 and 1. You could do the fluorine first and then the Na, but most people do it in the same order that it's written. So I'm going to draw a sodium ion. Sodium I'll do in black just so you can see. Sodium has 11 protons. How many neutrons? And then it's got an inner shell of 2. It's got another shell of 8. 1, 2, 3, 4. Pair, 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 pair. Normally, don't write this down. Normally, if it's an atom, it has that. This is why it's so reactive. It really wants to get rid of that electron, so I'm not going to draw that. It's an ion. How do I show that it's an ion? Square brackets. And the ion charge. Now I'm going to do fluorine. Now, am I ever going to ask you to draw a board diagram of, for example, iridium-3 phosphate? No. Because first of all, we would have to draw those covalent, and then that I'm not going to do the big ones with lots and lots of electrons. So if you're wondering, am I going to ask you to draw a board diagram? It's going to be from the first 3 rows of the periodic table. In fact, probably from the first 2 rows. In fact, probably from the second row, because the first row is boring. Fluorine. There it is. So fluorine has, good question, how many protons? 9 protons. Oh, hang on, I'm going to change colors, I said. Fluorine seems like a blue to me. 9 protons, 10 neutrons. It's got that electron shell. And then it has 1, 2, 3, 4, 5, 6, 7. And it's picked up that extra electron from sodium. Now it's an ion. How do I show that it's an ion? Square brackets. Other reason I'm not going to ask you to draw a bunch of these is they're time consuming, and there's a better way to show this. You'll learn some what are called I'm blanking on them. There's another diagram that's better than a board diagram. You'll learn it in Science 10. I'll remember the name in about 30 seconds when I stop. Lewis diagrams, there, when I stop thinking about it. They're much nicer. You don't, first of all, where is all the action happening in the outer shell? Fancy word? Okay. Lewis diagrams, all you draw is the valence shell. You don't care about anything in the middle because who cares? A little nicer. Draw a board diagram of MgCl2. How many magnesiums are there? How many Cl's are there? So I'm going to do the magnesium in the middle. Magnesium element 12. How many neutrons? Also 12. And it has one full innermost shell. And it has one full second shell. If we were drawing the atom, don't write this down, we would add two more. Are we drawing the atom? We're drawing the ion. We don't care about that one. To show that it's an ion, we're going to do this. 2 plus. Now we're going to do chlorine. I'll do chlorine in red. Chlorine has 17 protons. How many neutrons? 36 take away 17, 19? And chlorine has innermost shell of 2. Chlorine has a next shell of 1, 2, 3, 4, 5, 6, 7, 8. And it's got one more shell of 1, 2, 3, 4, 5, 6, 7. That's the chlorine atom. It really wants that full valence shell, so it's going to take one electron from magnesium to show that we did this on purpose, that it's an ion. We put the square brackets. And then if I'm lucky, I can use fancy schmancy digital technology and put it right there. Yo. 19 neutrons is, hang on, 17 protons. Why does it say 7? Okay. How would I mark these, by the way? So you ready? How many atoms did we draw? How many marks is it? I would probably go 1 mark per atom, and what I would do is I would take a half mark off for each mistake. Now, if you drew the wrong type, if you had things in circles overlapping, if you drew a covalent, I would start out at 0, sorry. But I would say, oh, they missed the plus sign, half mark off, or they missed the square brackets, half mark off, which basically gives you 2 mistakes per atom, and you've lost all the marks for that atom. Sorry. Okay? This one here, how many atoms? How many marks? That gives you 1.5 marks for each atom. So you can make 3 mistakes for each atom and still get some marks. And again, oh, are they wrong number of protons or neutrons? Half mark off for each of those. Missing a shell, half mark off for each of those. That's kind of how I mark these. I want to try and give you as many part marks as I can. So I want to reward if you know the basic concept. But here I got to be a little fussy. Here, 3 atoms, 1 mark for each atom, half mark off for each. Okay? So, I'm going to say this. You can put a score on the top of your quiz right now if you want to, or if you're going to do if you're going to do your corrections during class, don't bother putting your score on there. Do your corrections and just hand it in later on in class. If you're okay with your score, and some of you did have the hang of this, that's great. You can also hand in the take-home quiz in Block B right now. But if you want to do the corrections and fix the marks right away, best way, again, whoever, I think it was Jimmy asked, what if I got it wrong? This is the best way to do it right is do it wrong once, and now you're grumpy and you're like, oh, that's how I did it wrong. I won't do that again. So that's why I do the quizzes this way. I want you to have a chance to make mistakes, but not lose marks from those mistakes, so that you won't do them on the test when it does count. Is that okay? So let me pause the video for a second.